Assalamualaikum warahmatullahi wabarakatuh to Dr. Zami. Uh, we from Group A, we present about a wheeler sprinkler. Firstly, I will introduce our group members. First, we got Nodia Tuizati. And second, we got Muhammad Ibn, which is myself. Thirdly, we got Muhammad Was Akil. And finally, the Lingashwar. Okay, our problem statement is the farmers nowadays, if they want to fertigate the crop, they will use a knapsack. But the problem with the knapsack is it put the high stress on the farmer's body because of high weight of the knapsack. It also has a small tank volume for fertilizer, which need to be refilled in certain period. Third problem is it also has short sprinkling range, like around 2 meters around the farmer's body. And lastly, the farmers need a longer period of time to finish the fertigation of the crop. So our objective of this design project is to build a design that can reduce the overall farmer's workload. Second, we build a design to reduce stress on farmer's body. We also need to include the larger tank volume. And next is to also increase the sprinkler range of the fertigation to accommodate the price to be affordable to the farmers. Our target market is small scale and also medium scale plantation field. We also target the rural areas. Okay. Next, I will pass to Muhammad Wais.
Okay, for the next, I will explain about the technical requirement for our project. The first technical requirement is force required, which is between the 40 Newton to the 0 Newton. And next is the total weight, around the 400 kg and to the 50 kg. And next is the volume of tank, which is around 100 meter to 100 liter to 15 liter. And for the sprinkler range, we have 50 meter to 3 meters. And the sprinkler area coverage, it will cover 3 row each side in the garden. And for the time required to the finish per acre is around half an hour to 2 hours. For the east movement along the farm, uh, our project is, must not limited to the surrounding. After that, the component protection from the fertilizer, which will have a protective cover from the fertilizer. And lastly is the cost. The cost is between the RM 3000 to 100. And next slide. And this is our histogram graph for the technical requirement. As we can see, the load, uh, the graph is about the knapsack VS design project and the tractor for the fertilizer for the plant. As we can see, the load for the knapsack is quite high, which is 103, because we need to carry the fertilizer at our back. And for the our design project and tractor, we have a zero load. For the tank volume, we can see that the tractor have the most highest volume, which is 400. And for the range, we set our design project is the highest range, which is 50 meter. And for the times per acre in a minute unit, which is our design is the quickest to cover the per acre, which is 60 minutes. And lastly, the mass of the tank, water fertilizer tank, the tractor, of course, it is the bigger in the volume, which is in the mass, which is 470 kg. And that's all from me. Thank you.
Thank you, Wars. I will be explaining about the other design existed. First design that existed using the same concept for like our design is the mounted spray from Haster Equipment Malaysia and aligning spray Wuhan Ecam Agro Technology Co. So in this design, we compare the volume of the tank, dimension of the tank, mass of the tank, time requirement to finish per area, and the range of the sprinkler. We compare this with our design. So the first one for the volume, we can see that our design is in the middle between the aligning spray, which is 40 liter, and the mounted spray, which is 1,500 liter. So in part of dimension, our will be used for a medium size, like because the dimension for that is 71 times 24 and 2047, whereas the mounted spray has the highest dimension and the aligning spray has the smallest dimension. So for the mass of the tank, our design will be 72 kg, and the mounted spray will be 600 kg, and the aligning spray will be 50 kg. And the time requirement for our design to finish per acre is 1 hour, while for the aligning spray will be 2 to 3 hours, and for the mounted spray will be 1 hour 30 minutes. For the range of the sprinkler, so the design project the our project will require 15 meter, while the aligning spray will be 5 meter, and the sprinkle range for sprinkle say the for the mounted spray will be 8 meters. So this design have been researched in the US patent office, so it has been verified patent right equipment. That's all from me. Thank you.
So we have come up with 4 different conceptual design based on the technical requirements previously. So we will look straight to the design criteria. Okay, so for the force required to be applied by the farmers, only design one that may need larger force compared to the other designs, since those 3 wheels may bring instability to the movement, especially on a muddy land. So as for the total weight, design 3 and 4 both have bigger frame, which will add more to total weight. And next, since design 2 do not have frame to be restricted, it can fit a larger volume of fertilizer tank on the upper row of the wheeler sprinkler. So in terms of sprinkler range, assuming that all design use the same pump, the maximum range will be same, since the difference of the range will be too small, thus can be neglected. As for the sprinkler area coverage, a big gap between 2 boxes of sprinklers in design 1 and 2 make the advantages. Design 4 is the highest advantages thanks to the wider gap between the sprinkler in each boxes. So criteria for the next 2 criteria, which are the time required per acre and ease of movement along the farm, is mostly the same. So only design 3 has the disadvantages due to its unstable movement prediction. Next, only design 3 and 4 has maximized protection for the components thanks to the full frame. The final criteria is the cost. So from the estimation, design 1 will have the lowest cost since the part for the frame is not complex, with 1 less wheels compared to the other design. As for design 3 and 4, the big frame will resulting in higher cost since it means more materials are needed to cover all the main components. So at the end of our discussion and observation, we concluded that design 2 and 4 will be chosen to be evaluated further in order to determine the final design. So that's all for our progress presentation. Hope to see you soon later. Thank you.
Thank you.